Hello, class. Again, it's Mr. Cablan here, and I'm moving on with the fourth lesson in chapter two, okay, which deals with what are called linear and non-linear relationships. So, just to summarize what we did in the last lesson, I introduced you to three new terms, okay, trends, interpolation, and extrapolation. Now, just to do again a quick recap of those three terms, okay, remember that trend represents the general direction of a pattern of data, okay, and typically it's upwards or downwards. Now, remember in the last lesson as well, interpolation is making a prediction inside of a set of data, and extrapolation is making a prediction outside a set of data. So we're actually going to see those things again and how it ties into what are called linear and non-linear relationships. So if we take a look at today's lesson, let's proceed with that. So when we're dealing with linear and non-linear relationships, just to talk about those two words over here, okay, you should be familiar with linear. Okay, notice the key word in linear is the word line. So today we'll be constructing what's called a line of best fit, which is basically a line, okay, that describes the overall pattern of the data that's provided for us. So we're going to recap some of the stuff we did in the last lesson with this lesson and then tie in the new technique of actually drawing a graph to somehow connect the points to our best of ability. All right, and then we'll talk about nonlinear relations in the lesson in just 2 seconds. All right, so if you take a look at your graphs over here, okay, just to give you a good understanding of what a linear relationship is, it's basically given a set of data and figure out what the trend is. Okay, the line of best fit is a line that describes the overall trend of a set of data. So if you take a look at this graph over here, notice that if you take a look at the points without the line, okay, the points are going in a generally an upwards direction. Now, all the line of best fit is putting down your ruler and the points here is, and then connecting the points as close as possible to the line that you see there. Now, if you take a look at this example, the points are very close to the line. Now, not every point has to be in that line. All the point needs to do again is just to be able to accurately describe the overall pattern of the points. However, the points should be relatively close to the line here. Now, a general rule of thumb is when you're drawing a line of best fit, you should have an equal number of points on the line, okay, and an equal number of points above and below. So if you take a look at this example here, okay, notice we have approximately 2 or 3 points that are actually on the line, and then 2 or 3 points that are both above and below it. Okay, so that's an example of a line of best fit. Okay, we'll be seeing a lot of that in this course, believe it or not. All right, now when you have something that does not form a straight line, okay, we have what's called a curve of best fit. Okay, so if you take a look at this graph over here, okay, if you take a look at the points, first of all, without the curve, okay, you would see that the points would be generally going in a downward trend over here. Now, a good way to estimate whether you have a line or a curve is simply by putting a ruler down on the graph there and see if the points are close or near to the line. So if you put a ruler to your screen, feel free to try that. Okay, you will notice that it would look a little bit funny if you try to put a line through these points that are going down. Now, when you're looking at a curve of best fit, you're just basically going to freehand draw a curve, okay, that goes through most of the points, keeping in mind that you should have the same number of points above and below the curve. Now, for both the line of best fit and the curve of best fit, okay, you can perform interpolation and extrapolation in a similar fashion that we did in the last lesson. The only difference is that the line or the curve will be used as basically as the measuring stick for to determine those values there. So you're going to see an example of that, right? So that would be an example of interpolation of a line of best fit because I am estimating my values, okay, based on the line. Now you notice in this red line which I'm using as a guide, okay, if I were to determine what the value for y is for whatever x is, all what I would do here is to estimate based on the line. So if I go up here and once it touches the line and I go across, okay, this would be the estimate or the guess of that particular value. Okay, and remember, just like I said in the last lesson, interpolation and extrapolation can work in both directions. So if I want to determine the value of x for a certain value of y, okay, I can read the value like this across and then down, okay? So if you take a look at the curve of best fit, it goes in the exact same way as well, okay? Now again, as I mentioned a few seconds ago, we can also extrapolate the values using the line or curve of best fit by looking beyond the data. So if you look at the line of best fit over here, okay, notice that I'm making a guess beyond the set of data here. Now for this one over here, okay, notice that this last little dot over here would represent the last data point that we plotted as an ordered pair. Okay, but I also just want to clarify that when you're drawing a line of best fit or a curve of best fit, make sure you extend. And the reason for that is because when we extrapolate, we are reading off the line over here. So notice that we are reading beyond the given set of values. However, my guess or my estimate is based on the line. So I go up like this, and then once it touches the line, I go across, and I can make an estimate of what the y value will be. And same thing with the curve of best fit. Okay, so for this one, okay, notice I'm touching this line over here. So once this curve, sorry, once it touches the curve, I can then recross for it to make an estimate of what the value for y will be for a given x beyond a set of data. All right, so moving on, let's take a look at some examples. And again, this will just clarify anything that you might have questions on when it comes to what a line or curve of best fit will be. Now, the first example, we're going to talk about the inappropriate use of a line of best fit, or when we know whether a curve or a line is to be used. So if you take a look at these three graphs over here, all three graphs technically have something wrong with them, or there's an inappropriate use of a line of best fit, okay? Now, for the first one here, just by looking at this first graph and comparing it to the other two, okay, you probably notice that this one over here only has 4 points, whereas the other two graphs over here have, well, obviously more than 4 points. Now, the one thing you need to know about the line of best fit or a curve of best fit for the matter is that you need to have a lot of data. Okay, and you're gonna look at this in greater detail in a senior math course like data management. But again, that's something you just need to know in general when it comes to looking at graphs. And that's exactly what's wrong with the first part. Is if you take a look at the line over here, yep, we do have something that describes the trend of the given points, but the misuse of it, or the reason why it's technically incorrect, is the fact that there isn't much data. Okay, you do need a lot of data for you to have an accurate line of best fit. All right, second graph might be a little bit tricky to understand at first, but if you take away the line over here, if you look at the general pattern of the points from left to right, you notice it is going down in a downward trend here. Now, if you take a look at the line that is drawn, okay, it looks pretty awkward because if you take a look at the points are pretty much scattered above and below it. All right, as I said before, this is generally a downward trend. However, the line would be a misuse of it. Okay, so it would be an inappropriate use of a line of best fit because, well, the line does not fit through the majority of the points here. So what we have to do for this one here is that if drawing a line to describe the trend looks a little bit awkward, then the other option is to use a curve of best fit, which also describes a trend. Now remember, a curve of best fit is drawn using freehand. So as long as you connect the points there with a smooth curve that goes through at least most of them, or you have an even number of points above and below the curve, just like that, okay, that would be an example of a curve of best fit, okay? So in this case here, as I said before, the line would be an inappropriate use for it. So a better way to represent this data here would be a curve, all right? Now, last but not least, okay, this is literally a scatter plot because the points are literally scattered, okay? If we were to take away this line, okay, and you look at it face value, okay, you will see that there is no definite pattern, okay? It's neither upwards nor downwards. So this line over here is actually incorrect because this set of data has absolutely no pattern. Now, when data has no pattern, you still represent it with a line, but a very specific line, okay? So in order for you to represent something with no pattern, or you're gonna see later on, no relationship, all you need to draw is to draw a horizontal line from left to right, like so, okay? So this represents here the fact that there is no relationship or no connection between the points between the x and the y variables here, okay? So that's how you would represent something with no pattern or no trend, okay? All right, so next example, let's take a look at a word problem here. And in this case, what we have here is another version of a table of values, and this is the one that's commonly used. And what we have here is the depth in meters, okay, and the pressure measured in what are called kilopascals, which is just a unit of measurement for pressure. And what we want to do here is to graph this on the Cartesian plane. And before we do that, okay, just to talk about independent and dependent variable in terms of what goes on the horizontal axis and which one goes on the vertical axis. Anytime you're given a table of values that looks like this, okay, where you have, in this case here, a column on the left side, okay, and a column on the right side. Okay, quite often, again, more than 99.9% of the time, the left column, okay, is always going to be the x or the horizontal axis. So the depth you will label on the bottom like this, okay? Whereas the pressure, in this case here, that will be the vertical axis, okay? Now, to draw the scatter plot, each one of these will be an ordered pair. So, for example, if we were to use x and y, because that's what you're familiar with, okay, the x here would be the 5, and the y would be the 150 in this case. So, for the first point, I'm going to go right 5, okay, or right to where it says 5, and then I'm going to go up to 150, which is right there, okay? Next one here is 10 and 199. Now, remember that these are all points, and if you take a look at the numbers over here, every other box is going up by 100. So if you take a look at 199 and you plot that, okay, and you round it to the nearest 100, the nearest 100 there will be 200. Okay, so you can roughly just estimate that this point will be right there. Okay. All right, and then we have 15 and 248. So if you look at 248 and you really think about it, that's close to 250. So that's be right there. Okay, and from there we have 20 and 298, which is close to 300. Okay, and I think you guys get the general point there. Okay, we have 25 and 346. Okay, 30. We have 30 over here, and then 396, which is close to 400, just right below it. Okay, 35 and 445. And last but not least, we have 40 and 493. Okay, so we have a total of 1, 2, 3, 4, 5, 6, 7, 8 points on this particular graph. Now, if you take a look at the overall pattern, okay, so number 1, it is upwards. Okay, number 2, you notice from far away, and I hope you guys can see this right. I did this example on purpose, by the way. Okay, these points, okay, do form a straight line. And it's actually a very, very when these points here, you're going to connect them all with the ruler. They're actually all touching the line, like so. Okay, so this is a perfect example of a linear relationship because we are now connecting a line straight through all the points. Now, just to make some additional little tiny details here as well. Okay, notice I've extended the line in both directions because we will be using this line to make predictions. Okay, all right, so let's do that. So in this first example over here, this is describe the relationship with the data. So step number 1, always identify the trend. So I mentioned already that if you take a look at the points and the trend of all the points over here, okay, it is an upwards trend. Now, we saw this in a previous lesson, is that when we're describing the relationship, we have to see what happens in terms of what the independent variable does to the dependent variable. That's why when you're making a statement based on the relationship, you always have to state what the independent variable is doing first, then mention the dependent variable. That's why if you take a look at this sentence over here, it says, as depth increases, pressure increases. So you always have to state what's happening with the independent variable first, which in this case here is the depth. All right, so question D, this is use interpolation to predict the pressure at a depth of 37 meters. Okay, so again, if you look at this word interpolation, remember interpolation means making a prediction within a set of given data. Okay, and what we want to do here is to figure out the pressure when you have a depth of 37 meters. So if you look at your little table over here, notice we have 35 and we have 40. So 37 is somewhere in between. Now what you're going to do here is you're going to draw a line up and make it touch the line and then make a prediction going across like that. Okay, so when you're looking at that, this is 37. So when we go across, or up and across, sorry, okay, you notice it's going to be above 450, okay, and below 500. So for your guess for this one over here, you just have to say that it's approximately, in this case, 475 kilopascals. And as I said before, this is just a prediction. Okay, it's not exact, but based on the pattern and where it's located on the line of best fit, okay, that's going to be the best approximation based on the data that's given to us. All right, for part E, it says use extrapolation to predict the pressure at a depth of 60 meters. Now, recall that extrapolation is making a prediction beyond the set of data. So if you look at 60 meters over here, okay, notice that goes to a part of the graph that is beyond the points that are given. So when I go right to 60 and then I go up on the line and then across, okay, notice it's slightly above 650, but well below 700. So when you come up with your sentence to describe that, okay, notice at a depth of 60 meters, pressure is approximately 675 kilopascals, okay, because it's above 650, okay, and it's below 700. All right. Okay, so that wraps up this particular lesson, and I'll see you at the next one.